Okay, today we start chapter 8. Huh? Chapter 8, So yeah, so your test 2 will be equation of motion, kinetic problem, rigid body, test 2, Then your Newton laws, work and energy equation. Principle of impulse and momentum will not be in your test 2, but it will in your final. Okay. So basically you are ready for test 2 already. Basically So yeah. Okay. Chapter 8, we're still repeating the same thing from particles. We only look at principle of impulse and momentum, and then conservation of momentum. Okay, and then looks and some impact. Yeah. So again, when you look at rigid body, you only need to consider additional effect with its initial, the moment, the second moment, the initial effect. Right. The mass effect you already done in your particles. All right. Now this chapter 8. Why we study this one is like how the big boat can be pushed by a small tugboat. Right, this small boat. When this container ship you want to park in the port, sometime you need some small adjustment. So they send a small tugboat. This small boat here, we're going to push somewhere here. So this boat we're going to push at one of the point of the body, and then it will create some impulse to the body. Then it will start to manipulate the movement. Okay, all right. So just recap, what is angular moment, linear moment? Okay. Rigid body. Week 13, week 13. Okay. So okay. Now rigid body, we start with linear momentum. Right? What is linear momentum? We know that momentum, how to create momentum, it create with mass and velocity. Right? Now this is linear momentum. That is, you see this one in particles. Right? But when it comes to rigid body, we always focus on the center of mass. G. So you're focusing in rigid body, you're focusing everything happen to center of mass. It is the G point. You're only interested in the velocity of the center of mass, G. The rest equation is the same like particles. Okay. So you'll see something like this. So angular momentum. Just now it's linear momentum. What is angular? Angular, it involves rotation. Okay, it involves rotation. So just now linear, you link V, right? So you need to link angular with the V. So you know there's one conversion equation. We link your V and angular, which is V equal to omega R. So you just substitute this one in when you want to do angular momentum. Okay. So the rest you can read from the slides lah. Basically, it's the same. So you deal with vector, vector, vector. So from P to I, if you draw vector, Vi from P will be Vi minus Vp. So you want to write a positive equation, which is Vp plus Vi slash P equal to Vi. So this is a vector problem. And Vp stroke I, which is this line, P to I, is omega R, because it's a velocity. Velocity you link with angular, you get omega R, right? And angular momentum Angular momentum means you take momentum multiply by arm, R. So you take momentum multiply by the R, by the length of the arm here. Okay. All right. So at the end, I'll show you the n equation. Okay. I'm not interested to ask you guys the derivation. I want you to observe the difference compared to particles. Okay. So when angular momentum, in this case, we use h equal to arm times the momentum. Momentum is mv or m omega r. So at the end, you arrive at this equation. So when your rigid body, there are two cases. Rigid body, they have two concern or two perspective when you solve question. Sometimes you focus on G, sometimes you focus on the external point that is outside the G. So for chapter 8, we will combine, when your case, your interest point is aligned with the G point here, then you can eliminate all the derivation steps and arrive at this one. H equal to I omega. Okay. So this is how you solve it, right? So for equation that you learn in chapter 8, this is the new equation. You take I multiply by omega. Okay. This equation, when you can use this one, when your interest point is aligned with the center of mass. Okay. You can only use this one when your center of interest, this one inside here. What kind of case? Example, when you have a ring and there's a datum or there's a pin at the center of this, and the pin was on the same location as your this center of mass. Okay, this kind of case, yes, means the same location was intersect with the gravitational. So the equation that you see are very complex. You can ignore the blue color component. Okay, so you only arrive at h equal to I omega. Okay, in this case, so um, okay, so sometimes you need to identify if there is an additional point. For example, additional point, you need to calculate the I. What is the difficult part for rigid body is the I value. If it's IG, you can refer to table, right? If it is external, outside the center of mass, for example, point O, you need to calculate the IG plus MD square. You need to use this equation if you have external point that you need to calculate. For example, the one that you see here, let's say this one is external point. External point equal to IG plus MD square. Okay. Now, why this equation is here? Why this equation is this one? Basically, it's asks you to find this distance. Let's say this is the center of mass. This is the interest point. That is the different location from the center of mass. So this is the MD square. This is the D that you want to find. Okay. Right. Okay, don't worry. At the end, you just arrive at one very simple equation. Yeah, the rest you read, The rest you read. I will not go very deep in derivation. Okay, is this equation, it is angular motion of equation HP. If HP, this equation you use to calculate at external point, or I change this equation to O, right? I change this one to O. So minus Y bar M VGX plus X bar M VGY plus IG omega. Okay, so this is a bit different from the particles again. Right. So we are now chapter 8. We are talking about angular momentum already. Angular momentum. So you need to take the momentum multiplied by the arm. Okay. So mv is momentum, right? Momentum is mass multiplied by velocity. But when you come to angular, there's a word angular be in front of momentum. You need to add the arm, the distance to the momentum. Right? It's like you calculate moment. How you calculate moment? You need force and the perpendicular d, right? To get moment equal to ft, right? So same. This is moment, but you use the same principle for momentum. Momentum is, what is momentum? Momentum is mv, mass times velocity. If you need to take the angular momentum, you just need to multiply the distance to the velocity. So like same like this one. You just change the force become momentum. Okay. So again, rigid body, you have a few motion. Translation means you move in the straight line. So straight line in the equation here, you can eliminate one component, which is omega. Because if this object moves straight line, no rotation. So what is omega? Omega is angular velocity. So you don't have this rotation, so you can cancel this one. Okay, so you read carefully. If the question say that the object move along the surface, where you see that it's very obvious it is moved in a straight line, it cannot rotate, then you can this one you can cancel. You draw an arrow, then write 0. Okay. So okay. So linear momentum is one that you learned in your statics. With momentum, linear momentum is mv. But when you come to angular momentum is you need to use this equation. But in this case, because it's moved in straight line, so you don't have rotation. You don't have rotation, so omega 0. Then why this one 0? Why this one 0? Because your y bar, x bar is 0. Your y bar, x bar is exactly on the G point, the central mass. So the y bar, x bar is 0. Okay. We straight away, I show you the, okay, if you have rotation, for example, this case, you have a rotation, the object we will rotate at a fixed point. So still you have a linear momentum, which is mv from here. And this one rotate, you know that when things rotate at a fixed point, this one move in the curvilinear motion, right? Curvilinear motion, you have normal and tangent direction. Okay, but velocity, you only have one. Velocity, you only have tangent direction. Only acceleration, you have two components. Acceleration, you have tangent and normal direction. Okay. So when you're rotating, then your angular, when the thing rotate, then linear, you still having, you need to calculate mass multiplied by velocity. This is the normal momentum. But when you come to angular momentum, you observe the full equation here, because this one was rotate with the angular velocity. So you have angular velocity component. And the front one, y0, is because your interest point here is the same as the G, like the y bar. Okay, right. So, what else? Okay, so if you have a system like this, when you have a pin and to the center of mass, your equation, you only need to memorize this one. Ig omega plus R plus mv equation. This one is just a derivation. The important part, if you see reference point fixed, and then there's a center of mass, the equation they use to calculate angular momentum is I omega plus R plus the mv. You have this component, if you see this case. Okay. General plane means you combine two. General plane means you move in translation plus rotation. Okay. Then you have this equation. All right. So again, linear momentum, you need to start calculating linear momentum first for chapter 8 question. You need to calculate what is the linear momentum. You take the mass multiplied by the velocity at the center of gravity. If this one rotate, mean this one rotate in a circular motion, you always with a tangent direction. Or sometimes the question will straight away give you the velocity direction. Okay, then angular momentum, again, angular momentum, you use the moment principle or concept. You take Ig omega, right? And if you refer to this table, if you have a general plane motion, refer to A, not on the body, but to external far away. So your angular momentum will equal to I, what happened to the center of mass here, I omega, plus D. D is a distance with the perpendicular IC point, right? D and MB. So this is the formula, right? Okay. So general motion is like a datum system like this. So if you it's like the one that you do the impact test, right? Right. Too bad our equipment is broken, but it's like a mass here. Then if you lift up, then it will swing, right? So this is the datum, not datum, but there's a pin here that cannot move. So if you have this problem, you need to calculate where is the center of mass in the object. Usually it will be given. So you focus on center of mass, and then you calculate the momentum. All right. Ask yourself, what is momentum? Momentum is mv, mass multiplied by velocity, and it's always perpendicular to the radius here because it's moved in a circular motion. Circular motion, so you have tangent direction, right? And then previously you learned about I omega already. M equal to H equal to I omega. All right. So here, as you can see here, if you have this system, you are referring to O. Then your calculation, again, you need I omega plus D multiplied by the momentum. Okay, so this is a bit different from the particles. Particles, you don't have this one. Particle, you only have this one. Okay, what else? Okay, previously we show you the equation to derive velocity and link with the angular parameter, V equal to omega R. So to calculate the velocity at the center of mass, V equal to omega R. So what is the R? R is the D here. Okay, R is the D here. Okay. So at the end, if you have this system, again, though, just need to highlight. If you refer to the external point, you always need to use the IO equation. IO equal to IG plus MD square. If you use IO, there are two approaches. Sometimes the question will force you to use center of mass point. Sometimes the question will force you to refer to a certain external point. If the question asks you to refer to a certain point, for example, point A, point O, point B, then you need to use IG plus MD square. You need to convert this IO into IG plus MD square. You need to look carefully. Okay, so we straight to the application. So given an instant, M will be given, and and you have a velocity, this velocity, right? Determine the angular momentum about point central of mass G here, and about IC at that instant. Okay. Now, before you solve question, you logically think how this object will move. Will it move in translation, rotation, or general plane? So in this case, if you have a velocity at point A, this one will rotate like this one. To rotate clockwise. So when you rotate clockwise, you already have omega parameter already. You have omega, you have alpha also. This one come to in one set one. You have omega, you have alpha already. Okay, then we straight away go. So this one also, when you rotate, this one also will move a little bit, right? So this one, you push down here, this one rotate, not only rotate, but this one, the G, the point G here will also shift from here to here, right? So here, when it become straight, it will move to here. So it will move to the left also. So you have a general plane. So you draw free body diagram, point A and point B, and then point G. Okay, then your velocity, because this is a straight line, a straight wall, so your velocity will be straight line, 2 meters per second. Then VB also flat surface. VB will move in the flat surface. So you have VB, VA. Then recall, how do you draw the IC point? You still remember how to draw IC point? You use your ruler. Put on the velocity. Here, perpendicular, you draw one line. Here, you put your ruler, draw up perpendicular. This is where you find your IC point. Okay, then you have the length of this one. You have length of this one, you should able to find all these parameters. What is the length of this one? What is the length of this one? Or the angle inside the triangular. Okay. Then you predict the velocity of the central mass. The G will be moving somewhere here. All right. VG will be moving somewhere here. Why? How we know the direction of your velocity of your center of mass? This gravitational, it will rotate in the circular motion. So it will always perpendicular to your this line. It will always perpendicular from IC. You draw IC point to the center of gravity. Use your ruler again. Follow your ruler and you just draw VG. Okay. We are using IC method. Okay. So this question you solve using IC method. Use your ruler. First, you identify the velocity first. What is the velocity? In this case, very straightforward. You have the surface. You just follow the surface. VA go down, VB go left. Then you use your ruler. Draw where is your IC intersection point between two. Then you combine IC point to the gravity, to the center of mass. Then you use a ruler again. Follow your ruler, draw your VG. Okay. Why we are focusing on velocity here? Because we are now in chapter 8. Chapter 8, you need to focus on impulse and momentum. So you only focus on velocity rather than acceleration. Before chapter 6, chapter 5, chapter 6, chapter 7, you are focusing on acceleration because you are using F equal to ma. But when you come to chapter 8, impulse and momentum, you are focusing on velocity. Okay, then angle was given. You should be able to put in all the angle inside the triangular. So bottom 30, top also 30. What else? Okay, here also 30. Right. So you put in things that you can predict. So you have a loss of 30 angle over there. Then you put in the length. The length between the point, 2 meter, 2 meter. Okay. So you have a 2 meter over here, then 4 meter, cos something. Okay. All right. Okay, then you have omega clockwise because these things fall down like that, so it will turn clockwise. So basically, we have all the things we have in the free body diagram. Again, we are now in chapter 8. You deal with momentum. You are focusing on velocity. The effective way is to use IC, means you use your ruler, draw intersection point, and then you focus on omega. Right, IC point, and then omega, then center of mass. Okay. Then you start calculating what is your omega. Right. So your omega equal to, okay, how you get this one? Again, recall what is your V. V equal to omega R. You start to link velocity and angular velocity together. So you rearrange your equation, V equal to omega R. You want to find what is your omega. You take V divided by R. What is your R? R is this one. Okay. You take this one divided by the 90-degree radius. This come by two sides, it gives you the omega. Okay. Once you find omega, you can find Vg. Okay. Vg, what is Vg? Vg equal to omega R. So once you have the omega, the whole object will follow the same omega. Because whole object rotate in the same, no matter what point you choose, all the point will rotate in the omega term. So Vg here is omega R. So once you find your Vg, you can find your angular momentum. Angular momentum at the center of gravity, Ig fixed already, H equal to I omega, but in G location. So we will use angular momentum. We will use H, capital H for angular momentum. So in your final exam, don't use other alphabet. If you use other alphabet, please mention or please write in your answer angular momentum equal to, for example, you like to use P, then you use P, you write angular momentum P, then you continue to do. If not, then we will by default we will use H, capital H for angular momentum. Okay. You Ig, where you get Ig from table? From the table, this is a rod, so you refer to rod at the point G there. It gives you 1/12 md square or mr square. This one refer to table. Okay, omega already fine. You substitute, you get the answer. Right. So important is to give the direction of your momentum. So in this case, clockwise. In this case, clockwise. Okay. So any question for example 1? Very easy, right? Okay. Just give you a heads up. Your final exam have 5 questions, 3 compulsory, 4 and 5. This will be one of the choice, right? So this is impulse and momentum. One is chapter 7. Means the last 2 questions that you choose, right, is chapter 7 and chapter 8. Okay, so if you are weak in chapter 8 or you absent chapter 8, you still can do chapter 7. But just give you some hints. Normally, the last chapter will be very easy one. Okay. Normally, because sometimes you might think, oh, it's a last question, then it might very hard. Just yeah, okay. Just give you some hints, and you have 2 hours to solve 4 questions. The final exam is 4 questions, 2 hours, 10 minutes to read. So it's a 2 hours question. So each question maximum you can spend is half an hour. So the standard of question, it will be similar like your test 1 and test 2, but a longer steps. Okay. Okay. So just now we find the angular momentum at G already. So then you find because the question asks you to find angular momentum at G, you already find the first part. The question continue to ask you to find at IC. So IC is somewhere outside the center of gravity. So you actually modify the equation to become IG. This one, actually you modify this one become IO. What is IO again? IO equal to IG plus MD square. You just modify this one. H equal to I omega, you just modify this one to IO. IO equal to IG plus MD square. So you once you modify the IG, you can derive this equation I omega plus D MV. Okay. Again, where you find IG from the table. This is a rod. So again, 1/12 ml square in the G location. Okay. Omega you find just now. D, again, some of you might have trouble finding the D. D is what? D is the distance from G. That interest point to the G. That is the D direction. Not this one, not this one. So it's a center to IC to G. So then the rest you just substitute. Velocity you also find, right? So you find the angular momentum at IC point. Yeah. All right. So this other method, if you want, you also can find the front one. This one is use G point. This one is use IC point. So IC point also give you the solution. You still get the same answer. So IC also, again, IC is IG. This is, you assume this one is IO. IO equal to IG plus MD square. This is IG plus MD square. Okay. Okay. Yeah. So just need to pay attention to this one. You still get the same answer. Yeah. So first set is referring to G point, center of mass. So IG, you're referring to rod. This one is 4. That's why there's a 4 here. MD square or ML square if you refer to the table. You're referring to this point, this object. But when you come to IC point, you're referring to same. You're referring to same. IC. Yeah. So here, what is different from here? Here is G, this is IC. IC, you have IG plus MD squared. This is the external things. Huh? Okay, now example one already show you how to find angular momentum. Okay, then what is angular momentum? Angular momentum, you take linear momentum times the distance to that velocity. Okay, angular momentum H. Or in short, you can just memorize I omega. This one, if you are G, then G. If it's other point that the G, you just change to IO. IO equal to IG plus MD square. You just substitute inside here. Okay, if you need to find other point lah. Okay, so normal one is you use G. If it's external, IO omega. Just substitute inside here. Okay. So we start to introduce you principle of impulse and momentum. Okay. Principle of linear impulse and momentum. Based on the name itself, you already know. You focus on impulse, you focus on momentum. So we start to derive a little bit to refresh you what is impulse. F equal to ma. In this case, we're focusing on center of mass. So ma, you know that in chapter 1, a equal to dv dt. Right? So mass constant, you just put in there. So you actually pull the dt out. You can write as F equal to the rate change of your mv. Right? The mv is what? mv is momentum. But based on this mathematic model, you take your mv divided by time means the rate change of your mv. This is impulse. Yeah. Okay. So the rest is just a derivation that you will be used in your solution. So important is this one. You write F equal to mdv, then you derive. So for chapter 8, what you need to pay attention is the time and velocity. You need to write the boundaries condition for that particular body. So t first is what? Let's say 2 seconds, t equal to 5 seconds. Then what is the velocity at that time? Okay. So you do integration because this is a differentiation. You pull, when you have dt, you pull your dt to left hand side. So f dt, dmg, you integrate both sides. Left hand side, you get f dt. Right hand side, you get mv. Right? This basically is the principle of impulse and momentum already. But in the textbook, we always like to see positive linear equation. So what we do, we pull the negative term to the left hand side. So mv1 plus the impulse equal to mv2. Okay, so this one you learn in your particles already. Yeah. Okay. Again, I will show you your test one maybe in after your test two lah. So remember all the general equation have marks one. You write equation, you have at least 1 mark. Final, sometimes I give you 2 marks. Final, final at least some is 1 mark, some is 2. So like this equation, if you do question number 5, then you write this one, you get I think 1 or 2 marks. I forget. All right. Okay. So the rest is just illustration. So what does it mean? MV again is momentum. So you deal with the mass and MV. So you can see here initial momentum diagram, G, and then there is a velocity there, right? So always combine your velocity and mass, it becomes momentum. And this is rigid body. Rigid body, it has I omega. Rigid body have I omega with the momentum. Okay. plus the impulse. Impulse diagram, you have G and then omega time. Again, what is impulse? Impulse is that you take force multiplied by time, you get impulse. So whatever that you have in your free body diagram that is force, it will create impulse. This one, whatever you see in your free body diagram that is force, your weight is force. What else? External also will create force. So you see all the external force here will give you impulse. Internal weight also give you impulse. Moment also give you impulse. Okay. Then equal to final momentum. Okay. Again, important is this, the one I highlight on the screen here. Okay. This is principle of impulse and momentum. So when we add one more, the word principle of angular impulse and momentum, then you need to consider the second moment of inertia, means the inertial effect. So if you have a body that go through general plane motion, means translation plus rotation, you have two motion, then the moment at center of mass will equal to I alpha. Okay, so this one you learn in your chapter 7 already, M equal to I alpha. So you recall the definition. What is alpha? Alpha is acceleration, but in angular term. So you take omega divided by t. We are deriving the equation now. So you do the same. You pull the dt out. You have I omega. Then you pull the dt to the left hand side. You integrate the equation. Right? You pull the dt to the left hand side. You will get this one. So mg t give you one term, and then I omega. So this equation, so if you have this, the first one here is on the center of mass, G point. So if you have a point that outside the G point, the center of mass, what you do, you use IO. Again, what is IO? IO is IG plus MD squared. Okay, this one. Yeah, so they have two equation here, but it's still same. It gives you angular impulse and momentum. M multiplied by t, moment and time, it gives you momentum. But I omega, it gives you angular impulse, right? Right. So just need to be careful. I mean, the question that you see in your assessment will be very direct. It will tell you use what principle. Okay, use one principle to solve what. Okay. Okay. So both are the same, only the focus point is a bit different. The middle, this one is focused on center of mass. This one at center of interest at outside the center of mass. It can be O, it can be A, it can B, it can be C. Okay, so these are the equations that we expect if in chapter 8 question. First is linear impulse and angular impulse. You need two to solve chapter 8 question. So linear impulse is what you learn in your particles chapter 1 until chapter 5. Okay, mv plus ft equal to mv2. Today you learn something a bit new, which is I omega plus mt moment multiplied by time equal to I omega 2. Okay. Right. Okay, the rest is illustration. Important is I will show you how to apply this one. So basically for chapter 8, these are the important equation if you want to solve chapter 8 question. You pull out linear equation, linear momentum, linear impulse and momentum equation, and angular impulse and momentum. Okay, like how to find IG, how to find VG, how to find MG, all this already covered in the chapter 6 and chapter 7. Right? Okay. The rest you read, huh? The rest you read. Okay. Okay, the rest you read. But the concept here is the same. Means that for linear momentum, linear means you move in a straight line. When you move in a straight line, you can change into x direction and y direction. So that's why your equation here can break into x and y. Okay. Okay, the rest. Okay, let's apply this one. Okay. Example 2 is a disc. We lock at A and then rotate. Okay, with a force 50 Newton. Radius from A to the outer ring is 0.2. You have a moment. Now, in chapter 8, when you see moment, it means very high chance you need to use the angular momentum equation, principle of linear momentum. So, you're given mass, constant, coupled moment 6, force, so and so, apply and route around. Determine angular velocity of the disc 2 seconds after. So, chapter 8 will give you time to determine. When you have time, means you can find impulse already. Because force multiplied by t is impulse. Momentum, moment multiplied by time also impulse. So this is the trick lah. When you see question, you know what you need to do. What is the force component, reaction, and pin? So when you have pin, you have go up and go to the left, go to the right, or anything. When you set positive, then when you get negative means the one that you predict in your free body diagram is wrong. Okay. Now, I teach in my diploma student class. How do I know that this pin or at my ring there is go up or go down? You always imagine you are the object. Let's say you are the A, right? You are A. You have something on your head, right? If you put the disc on A, you feel the disc will pull you down because of the mass. So if you are A, you are feeling there's a AY pushing there, right? Then if you pull this one, you imagine you are the A and the thing is rotate this way. So you tumble to this side, right? So there's a force pulling to the left hand side. This is AX. But you know that this is a coupled system, means you have to balance everything. So for the this is the opposite lah. So this one is go up, this one can go this way. So for the O, for the this reaction that you see, I'll just put as A, AY, and AX. Although both are labeled as AX and Y, but they on the different body, they will feel different things. Yeah, this is how I analyze the force component. So you draw free body diagram, determine where is the positive, negative direction, X positive to the right, Y going up positive. So you draw free body diagram. First thing you put in your free body diagram is to study the motion. So this one you pull force 50 Newton, it will rotate clockwise. So your omega will be shown in clockwise already. Then you put everything in a clockwise positive. You follow the motion of the body. The reason is we want to change all our equation to become positive. if you follow the motion, your equation will get positive value. So you focus on point A, put in the radius, put in the force, put in the omega. Okay, there's one careless mistakes when students do rigid body, especially when it comes to chapter 7, chapter 8. Some students you'll forget the weight already. You will so focus about external things. You at the end you will miss out omega when it comes to last two chapter. Okay, I don't know, somehow we see this kind of this kind of case. Right? When it comes to last two chapter, you can do all the force, but you'll miss out omega. You'll miss out the weight. You forget the weight. I don't know where. So remember, include the weight. Then the force, AX and Y. In this case, I'll just put randomly, go up, go to the right. Okay, then you put in the moment and all this. Okay. So you start to calculate the moment of inertia A. This one you can refer to table. Right? A is your O or your G in the table. So you will see half ml square or mr square. So you just copy lah, right? So from there you find the second moment inertia at point A or at the disk, right? Again, if you really don't know how to find this equation, just go to the table, look for the shape, and then this one at the center. So you just look at the center equation, right? And substitute lah. Okay. Then application of principle of impulse and momentum. You just write out the principle of impulse and momentum, mv before plus impulse f multiplied by time equal to mv after. So this one, you have x and y direction. And then one more for moment one. I omega before plus moment multiplied by time plus I omega after. Okay. The rest you already have already. You just substitute all the value. Okay. Important, I need to highlight these three equations. Basically, it's two equations, but the first one you break into x and y. Okay. So first one, mv square. Mv, the first one is 0 because there's no velocity in x direction. That's why 0. We focus on A. A do not move. So velocity 0. So 0. Then mv2 also 0. Because velocity at x direction for A is 0. Okay. But you have impulse. All the force you see in the free body diagram will give you impulse. Right? So AX in x direction will give you impulse. For Y, also same. Velocity of Y 0. Then the rest is impulse. So you have AY forces for 2 seconds. Question give you 2 seconds. Weight also 2 seconds, but negative because your direction go down negative. Then you have 50 Newton go down also negative. Then what about your velocity at A? Also 0 because A cannot move, it's a pin. Then the same, I omega 0. Right? Before start, it start from rest, so no spinning. So 0. MA is 6 external. A is 0. Is 6. Then 2 seconds. Okay, why all these force do not create moment? Because it's at the center. The D is 0, so no moment. But there is a 50 Newton here, create moment. If you put here this moment, so 50 times the radius, you get moment. So you get 50 multiplied by I think something wrong. My answer here is wrong already. It should be 50 multiplied by 0.2 times time. My answer here is wrong. Because here I'm calculating the moment. This is not moment, this is force. So if I put here, how to convert this force into moment? I need to take this one multiply by the radius to get moment. So there's something missing in my answer here. 0.2 times the time. Okay. Then omega 2, IA you already calculate already, 0.2. Okay. Then omega. So the rest, solve the remaining one. Okay. Okay, the rest, if you solve, you're able to do lah. Huh? Okay. So I think we have a short break. Okay. Let me check. Let me check the PowerPoint slide. How many slides we have here? Okay. You want to save it for next week or you want to next week? Okay lah. Okay, then we stop here. We continue next week.